Yes, I bid you a warm welcome to a mathematics class whereby you are going to enjoy yourself. There's this common saying by students that mathematics is very difficult, but I'm assuring you, you are going to enjoy this class. Mathematics made easy. So feel free, relax, and enjoy this class. The first topic we are going to start with says number-based system. It's a very simple topic. But let's see how this topic goes down. Number-based system. We look at change of base, how to move from one base to another. Then the first one we are going to use as our tool is the expanded notation. How is this going to be applied? We are going to take, for instance, letter X and see how we expand letter X. It is a tool. Expanded notation is a tool that we are going to use in number-based system a lot. It's going to help us. But let's first of all know what expanded notation is. Before we do this, we are going to take as a case study letter X. Take, for instance, you have a decimal number X, which we can be expressed uniquely in the form X, for instance, equals to I base n subscript down. We're not going to write the n to be of equal length or height with the capital letter I times, that's in power of 10 is to power n plus this I n decreases by 1 times 10 raised to power n minus 1 plus I n minus 2 times 10 raised to power n minus 2 plus I n minus n times 10 raised to power n minus n. This is the expanded notation form. So this is what we are going to use. It's going to serve as a tool anytime we are asked to expand any number at all in any base, in any number-based system. We are going to look at some examples together. We look at these examples and see how we are going to expand them. It is believed that every natural number, every number is in base 10. So we are going to look at some examples together. Let me just say example 1. Let's look at the following example together. Express the following in an expanded notation form. A 45078, B 930.133, C 0.0235. So we are going to work on the following questions now using this method, this expanded notation method. The first one we are going to do is question A. Let's look at the solution on how we are going to solve this very question using this expanded notation method. Let us solve this question together. 45078 in an expanded notation method or form. Just like I told you, you will label it from 0, 1, 2, 3, 4. Every number is assumed to be in base 10. So here now you're going to start 4 by 10 is to the power 4 plus this 5 by 10 raised to the power 3 plus 0 by 10 raised to the power 2 plus 7 by 10 raised to the power 1 plus 8 by 10 raised to the power 0. That is all. Because we are asked to write in expanded notation method. The second question, 930.133. We label from here. This is having decimal. So there is a way you will label the decimal different from whole number, because this is a whole number, right? After this point it becomes decimal number. So from here you still label as normal 0, 1, 2. But from after the decimal point here, start labeling -1, -2, -3. So from here now you start 9 times 10 raised to the power 2 plus 3 times 10 raised to the power 1 plus 0 times 10 raised to the power 0 plus 1 times 10 raised to the power -1 plus 3 times 10 raised to the power -2 plus 3 times 10 raised to the power -3. This is just an expanded notation of this. And the last question, 0.0235. Now, label this one 0, -1, -2, -3, -4. We start this way, 0 times 10 raised to the power 0 plus 0 times 10 raised to the power -1 plus 2 times 10 raised to the power -2 plus 3 times 10 raised to the power -3 plus 5 times 10 to the power -4. This is how to do the expanded notation form. Now, let us assume that you have to convert numbers, a question containing both numbers and letters. How are you going to do that? We have some series of examples to solve this. So, like we were saying, note that in base 12 there are 12 unique digits, but we are only used to only 10 single digits. Now, in this example given to you, you see that from question B, you have letters B, 7B, 3A, 6D, 4F. Now, we only have 10 unique digits, just like we have said here. So, what about all these letters that are occurring? Now, this is what we want to do. We use what happens to the remaining two letters. Letters are generally used to represent these digits. So we denote A starting from 10, B will be equals to 11, C will be equals to 12, D will be equals to 13, E will be equals to 14, and F will be equals to 15. Now we want to work on all of this. We are asked from the example that we should convert the following number to base 10. Just like that expanded notation we used earlier. Let's look at solutions now. Solutions. To the first question, A. 1, 2, 3, 7, base 8. The expanded notation form, don't forget, we'll start labeling 0, 1, 2, 3. But the base is being indicated to be base 8. So we'll just expand based on what we are given. Note to those examples we solved earlier that they are just given without writing the base underneath. Take for instance, the first question we solved says 4, 5, 0, 7, 8. It was not indicated in any base. So we assume that, it's always assumed that every natural number is given in base 10. That's why we expanded in base 10. But this time around it's given in base 8. So what we are going to do in this way is by expanding it in base 8. So after expanding now, don't forget that we are asked to convert to base 10. So after expanding it in base 8 now, we'll now do final answers. Write the final answer to the question. So we start with 1 times 8 plus this raised to power 3 plus 2 times 8 raised to power 2 plus 3 times 8 raised to power 1 plus 7 times 8 raised to power 0. Now note that anything, be it number or letter raised to power of 0 is equals to 1. So from this solution we want to get now, 8 raised to power 0 will automatically change to 1 based on this condition that is given to us. One thing about mathematics is that it requires law. You follow the law. So far you apply the principle or the law that is behind it, you don't have any problem. So anywhere you meet anything raised to power 0, just write 1. In fact, no matter where you go in the whole world, it is generally acceptable. So now let's completely put solutions now to this very question. Let's see. Let's find solution to the question. Let's find solution to the question. 1 times 10 raised to power 8 in power of 3. That will be 8. 1 times 10 raised to power 8 times 8. That is in 3 places. Plus 2 times 10 raised to power 8 times 10 raised to power 8 plus 3 times 10 raised to power what? 1 plus what? 7 times 8. Anything just like we said raised to power of 0 is 1. So this one will be 7 times 1. That automatically changes to 1. Now 8 times 8 is 64. If you use your calculator, 64 multiplied by 8, that will give us 216. That is 64 times 8. 8 times 4 rather 32. Carry 3. 8 times 6 48. 48 plus 3 48 for 9 50 51. So sorry, give us 512. So here now we are going to have 1 times 512 plus 8 times 8 64. 64 times 2 will give us 128. 128 plus 3 times 8 is 24. Plus 7 times 1 is 7. 1 times 5 112. That will be 512 plus 128 plus 24 plus 7. So let's add all of them together. 512 128 24 7. 4 plus 7 11. 11 plus 8 19. 19 plus 2 that is 21. Carry 2. 2 plus 2 4 plus 1 5. 5 plus 2 7. 5 plus 1 6. It gives us 671. 671 base 10. So we have successfully converted 1237 base 8 to base 10. 1237 base 8 to 671 base 10. So two of them are equivalent. This is to base 8 and this is to base 10. One thing I would still like to call our attention to is this. If you look at all these numbers, you see that all of them, they are less than base 8. 1, 2, 3, 7. All the numbers are less than base 8. If you check this place, you have 6, 7, 1. All of them are less than base 10. What we are trying to say in essence is this. In any base system, the numbers involved must not be up to that base we are talking about. So if, for instance, now we have these following numbers like 1, 7, 8. This one number can never be in base 5. It can never be in base 6. It can never be in base 7. It can never even be in base 8. So the only base that it can be is base 9 or base 10. So the base must be higher than the number in question. So please take note of that anytime you are operating a number-based system. Now the second question we are going to lay our hands on is question B that says 7B 3A 12. We want to convert it to base 10. So let's work on that now. Let's work on that very well now. Let me rub this down part off. Let's work on the second question. Believing that you have this question already in your notes, I will rub it off so that I'll be able to solve this. Later, I'll bring that question up again so that we can solve. So it's still the same thing we are going to do. We apply the same principle. We label from 0, 1, 2, 3. It is very, very important that we know how to label so that when we are solving, will not be difficult. So we start is already in base 12. So 7 times 12 raised to the power 3 plus b times 12 raised to the power 2 plus 3 times 12 raised to the power 1 plus a times 12 raised to the power 0. Now 7 times 12 times 12 times 12, that is what it means, raised to the power 3, plus, note, b, just like we have said earlier, we have been given, according to those digits, the letters we are given, a represents 10, b is 11. So we can just come in by representing that b with 11. So here will just be 11 times 12 times 12 plus 3 times 12 plus a is given to be 10 times 12 raised to the power 0. We said it earlier that anything raised to the power 0 is 1. So now, let's now use our calculator. But I will advise you as a mathematician that you have to go and learn your timetable very well. If you want to become a guru, let me put it so to speak, in mathematics, if you want to be very good in mathematics, you have to know your timetable very well. So I will advise you to go and sit down. It's a common thing. Don't be ashamed of it that you are too big to learn your timetable. Sit down in your private home, relax and learn this timetable, because it's going to help you a lot. With it, you're going to go far. So let's try to multiply what we have there. Let me continue from here. Don't forget, a is 10, b is 11. So if you can start from a is 10, so you remember all of them. No need of stressing yourself that what is letter F or what is letter E. So just start that a represents number 10. So from there you continue, b will be 11, c will be 12, and on like that. Now let's find a solution to this now. 12 times 12, let's start from there. 12 times 12 is 144. Then 144 times 12, let's try to, 2 times 4, 8, 2 times 4, 8, 2 times 1, 2, 1 times 4, 4, 1 times 4, 4, 1 times 1, 1, 8, 8 plus 4 will give us 12, 6, 7, 1. That is 12 times 12 times 12 will give us 1728. So 7 times 1728 plus 11 times 12 times 12, that is 11 times 144, because 12 times 12 is 144. Then plus, let's rub this one off. We have already through that part. So plus 3 times 12 plus 10 times 1. So 7 times 1, 728. Let's multiply that out. 7 times 8 will give you 56, you carry 5. 7 times 2, 14. 14 plus 5 will give us 19, you carry 1. 7 times 7, 49 plus 1, 50, you carry 5. 7 times 1, 7 plus 5, that will be 12. So it gives us 12096 plus 11 by 144. 144 times 11. 1 times 4, 4. 1 times 4, 4. 1 times 1, 1. 1 times 4, 4. 1 times 4, 4. 1 times 1, 1. 4, 8, 5, 1. So this one will give us 1584 plus 3 times 12. That will give us 36 plus 10 times 1 is 10. So we want to add all our numbers together. 12096 plus 154851 and 36, then and 10. 6 plus 6, 12 plus 4, that is 16. You carry 1. 9 plus 8, that will be 17. 17 plus 3, that is 20, 21 and 22. Carry 2. 5 plus 2, 7. 3, 1. So our final answer 13726 base 10. So that is the answer we have gotten. So converting 7b 3a base 12 is equivalent to 13726 base 10. So that is it on that aspect. Now the last question, just like I told you, I wrote down off earlier. I believe you already have it inside your notes. I also have it in my note here. I'm going to bring the question up so that we solve that. Then we'll be through with this section. The question says, 6d 4f base 16. So we also start our normal numbering 0 1 2 3. So we'll start with 6 by 16 raised to the power 3 plus d by 16 raised to the power 2 plus 4 by 16 raised to the power 1 plus f by 16 raised to the power 0. Now we multiply 16 3 times. 6 times 16 times 16 times 16 plus our d. Don't forget, you start from a. A is 10, b is 11. A is 10, b is 11, c is 12, d is 13. So d is 13 here. 13 times 16 times 16 plus 4 times 16 plus f. D is 13, E is 14, F is 15. So we now have 15 times anything raised to the power 0, just like we said earlier, is 1. So now let's try to multiply everything out. Let's try to multiply everything out. Believe me, you have copied this part. I will rub it off. Let's multiply them gradually. 16 times 16, 6 times 6, 36, carry 3. 6 times 1, 6 plus 3, 9. 1 times 6, 6. 1 times 1, 1. 6, 9, 10, 11, 12, 13, 14, 15, 15. Bring 1, 256. So multiply by another 16 again. 6 by 6, 36. 6 by 5, 30, 33. 6 by 2, 12. 12 plus 3, that will give you 15. 1 by 6, 6 by 5, 5 by 2, 1, 6, 9, 10, carry 1, 2, 3. So it gives us 3096. Let's just multiply at once by 6 again. No need of wasting our time much. So let's just multiply out at once. 6 by 6, 36, carry 3. 6 times 9, we have 54. 54 plus 3, that will be 50, 54, 55, 57. Sorry, 57. You carry 5. 6 times 0, 6. 6 times 0, 0 plus 5, 5. 6 times 3, 18. So this is our answer. 1, 1, 8, 5, 7, 6 plus 16 by 16. Recall that it gave us 256. So we just use only 13 to multiply that. 256 multiplied by 13. 3 times 6, we have 18, carry 1. 3 times 5, 15, 16. 3 times 2, 6. 1 times 6, 6. 1 times 5, 5. 1 times 2, 2. 8, 12, 11, 12, 3. So this gives us 3228 plus 4 by 16. That is 16 times 4. That will be 4 times 6, 24, carry 2. 4 times 1, 4 plus 2, 64. So it gives us 64 plus 15. Plus 15. Now let's plus everything together to get our final answer. Let's cross everything together. So we have 18576 8223 64 and then 15. Let's add 8 plus 6, 14 plus 4, 18, 19, 20, 21, 22, 23, carry 2, 9, 9 plus 1, 10, 16, 16 plus 2, 18, carry 1, 7, 8, 11, carry 1, 2. So this is our final answer. This is where we are going to put it on note. Don't forget, we just converted 6D 4F base 16 to 21883 base 10. This is what we have just done. So I would like you to go through what we have done for today. In our next class, I'm going to introduce you to some terms in number-based system. Then we'll solve some questions that might be strange. Then we can even go as far as checking some questions in the past question. You see that this topic
Very interesting and very simple. So till our next class again. Thank you very much.